Now let's do this very, very quickly. My students usually have problems with this kind of question. Let's do it together. This is from year 2014 and it's number 15. 15. This is 15A. A with coordinates -1, 2, B 3, 5, and C 4, 8 are the vertices of triangle ABC. Forces whose magnitudes are 5 newtons and 3√10 newtons act along AB and CB respectively. Find the direction of the resultant of the forces. Okay, let's represent, let's do this. Let me represent A, B, and C this way. This is the horizontal axis, and this is the vertical axis. This is the origin. A has coordinates -1, 2. That means OA. This is the origin. OA. Let me make this OA. Yeah, this is -1 and this is 2. So this is A. OA will be -I plus 2j. OB will be 3i plus 5j. Let this be OB. This is OB. Let this be OB. 3i plus 2j. This is B, and that's 3i plus 5j rather. 3i plus 5j. Wow. That's 3i plus 5j. While OC is 4i plus 8j. Let me put OC here. 4i plus 8j. 4i plus 8j. This is C, and OC is 4i plus 8j. Now, AB forces of magnitudes, forces whose magnitudes are 5 newtons and 3√10 newtons act along AB and CB respectively. Find the direction of the resultant of the forces. Let this be AB. This is AB. This is AB. Now AB is the same as AO plus OB. That's AO plus OB. AO plus OB. And I know that AO is the negative of OA. So that means AO is minus OA plus OB. And that's equal to minus into minus I plus 2j plus OB. This is OB. 3i plus 5j plus 3i plus 5j, and that's equal to I minus 2j plus 3i plus 5j, which is equal to I plus 3i is 4i minus 2j plus 5j is 3j. So that means AB equals 4i plus 3j. Now let me find the magnitude of AB, and that's equal to the square root of 4 square plus 3 square, which is the square root of 16 plus 9, and that's root 25, which is 5. The next thing is to find the unit vector in the direction of AB. Let U be the unit vector in the direction of AB, and that's given by AB divided by the magnitude of AB, which is equal to 4i plus 3j, that's AB, 4i plus 3j divided by the magnitude of AB, which is 5. And I can write it simply as 1 over 5 into bracket 4i plus 3j, or even better still as 1 over 5, and write it this way in column form. Now that is the unit vector in the direction of AB. Now, since the force which acts along AB has a magnitude of 5 newtons. Has a magnitude of 5 newtons. That means the force itself, let the force acting along AB be F1. Its magnitude is 5 newtons. So that means the force itself is given by the product of the unit vector in the direction of AB and the magnitude of the force acting along AB. So we multiply the unit vector in the direction of AB, which is this, by the magnitude of the force acting along AB to get the force itself, to get the force which acts along AB. We were given its magnitude, but now we are finding the force itself, and that's simply 4.3. Of course, 5 here 1, 5 here 1, and that's going to be 4.3 newtons. That's F1. Now I want to find the second force, but before then, let me find CB. Let this be CB. This is CB. This is CB. Yes, CB is CO plus OB. CB is CO plus OB. So let's find that. We need to find CB equals CO plus OB. We also want to find the force which acts along CB. We were given its magnitude. We want to find the force itself, so that when we know the two forces, the one acting along AB and the one acting along CB, we'll be able to find their resultant and then the magnitude of that resultant. So CO plus OB, CO is minus OC plus, so CB is equal to CO plus OB, which means minus OC plus OB, and that's minus into OC. What is OC? OC is 4i plus 8j. So minus into 4i plus 8j plus, what is OB? Let's see that. OB is 3i plus 5j plus 3i plus 5j. 3i plus 5j, and that's minus 4i minus 8j plus 3i plus 5j, which is equal to minus 4i plus 3i is minus I, and then minus 8j plus 5j is minus 3j, which simply means CB is equal to minus I minus 3j. Therefore, the magnitude of CB is going to be equal to the square root of minus 1 plus the square of minus 3, which simply means the square root of 1 plus 9, which is the square root of 10. So that is the magnitude. Of course, the square of minus 1 is 1, the square of minus 3 is 9, 1 plus 9 is 10. So the magnitude of CB's rho is the square root of 10. Now, let V be the unit vector in the direction of CB, and V is given by the vector CB divided by its magnitude, which simply means minus I, this is CB, minus I minus 3j over magnitude of CB, which is root 10. And that's simply, I can write that as 1 over root 10 into bracket minus I minus 3j. Or this way, 1 over root 10 minus 1 minus 3. Now, the force acting along CB, let the force acting along CB be F2, and that's given by the unit vector in the direction of CB multiplied by the magnitude of the force acting along CB, and that magnitude is 3 root 10. That's 3 root 10. The magnitude of the force acting along CB is 3 root 10, and this simply means root 10 cancels root 10, and that's going to be 3 times minus 1 minus 3, and that's simply minus 3 minus 9 newtons. That's the force acting along CB. Now, if R, let R be the resultant of the two forces. R equals F1 plus f2, which is equal to, what's f1? This is f1. Yeah, this is f1. So that's what I'm going to write. 4, 3 plus, what is f2? This is f2. Minus 3 minus 9. And that's the same as, of course, 4 minus 3, that's 1. 3 minus 9, that's minus 6. That's a resultant force. So how do we find the direction of that resultant force? I can sketch that this way just to make it easier. That's the horizontal axis and this is the vertical axis. It is 1 minus 6, so it is it's going to be on the negative y-axis. So that simply means this is 1 and this is minus 6. Of course, this is the right angle. This is the angle it makes with the positive x-axis. Now let's find theta first. The direction of the resultant is this. This is the direction of the resultant force, this angle. So it's going to be 90 plus theta. And that's simply, let's find theta first. So tan theta equals opposite over adjacent, which is 6 over 1. You don't need to put the minus sign. That's just to show the axis on which the vertical component of to show the vertical component of the resultant. It will let you know whether it will be on the positive y-axis or on the negative y-axis. Now, so that simply means theta itself will be the tan inverse of 6. Let's check that. What's the tan inverse of 6? Tan inverse of 6. That's 80.53538. Let me call it. That's 80.538 degrees. Therefore, the direction of the resultant is going to be, of course, we already said that it is 90. It is 90, the whole of this, which is 90 plus theta. 90 plus theta, and theta is 80.538. And that's simply 170.538 degrees, which is approximately 170.54 degrees. That's 174.54 degrees. And that's it. Very, very, very simply. Let's take the second one, which is B. A particle starts from rest and moves in a straight line. It attains a velocity of 20 meters per second after covering a distance of 8 meters. Calculate Roman figure 1. This is B, Roman figure 1. Its acceleration. This is a piece of cake. U is 0 meter per second. V is 20 meters per second. This is a piece of cake, especially to physics students, and furthermore students are mostly students who offer physics too. That's a bonus to them. Now, we want to find acceleration. This is a formula which relates velocity, final velocity, initial velocity, and acceleration. V squared equals u squared plus 2as. That's the formula. Yeah, which relates velocity, final velocity, initial velocity, acceleration, and distance. They said it covered a distance of, it covers a distance of, it attains a velocity of 20 meters per second after covering a distance of 8 meters. So that means the formula we're using is v squared equals u squared plus 2as. And that simply means 2as equals v squared minus u squared. This is v squared minus u squared. And a is v squared minus u squared over 2s, which simply means 20 squared minus 0 squared over 2 times 8. And that's equal to 400 over 16. Let's check that. What's 400 over 16? And that's 25 meters per second square. That's its acceleration. Now Roman figure 2 says calculate the time it will take to cover a distance of 40 meters. Calculate the time it will take to cover a distance of 40 meters. Now S is 40 meters. And the formula we are going to use here is S equals UT plus half AT square, which simply means 0 times T plus half times 25T square. Let me write that well. That simply means 0 times T plus 1 over 2 times 25T square. And that simply means, by the way, I already know the S. S is the time it will take to cover a distance of 40 meters. So I should say 40 equals 0 times T plus half times 25T square. And that simply means 40 equals 25T square over 2. And this means 25T square equals 80. So T square is 80 over 25. And that means T is the square root of 80 over 25. Which means, let's check that. What is 80 divided by 25? That's 3.2. And the square root of that is 1.789. T equals 1.789. Let's check that again. 1.789, yes. And that's approximately 1.79 seconds. 1.79 seconds. And that's it. Very, very, very simply. All right. Thank you very much. And I'll catch you in the next. Bye-bye.